Happy to have you all with us. So as Rex mentioned, I'm the Vice President of International Business Development. I'm also fortunate to work with all of our Canadian operators as well, and have been working with a few of our clients over the last 3 years on some of these Alt-LDAR, or what we call in Alberta Alt-FEMP programs, and have had considerable success. And so we'd like to review that with you today and talk about some of the wins and some of the highlights that we've seen as we work through these programs using continuous monitoring. So the goal of these programs, we have 3 goals really. The primary one is to achieve emissions reduction through alternative LDAR technologies. There's been a wealth of new technologies introduced in this space, and so regulators are now more accepting of some of these alternative technologies if the combination of operators and service providers can show that equivalent or better emissions reductions are achieved through the use of these programs with an associated work practice. So here in Canada, originally the targets were a 45% emissions reduction compared to 2012 levels by 2030. And more recently, those have increased to a 75% emissions reduction compared to those 2012 levels compared to a traditional LDAR program. And so right now, a traditional LDAR program may have instances of either annual or triannual optical gas imaging programs, surveys that are conducted. However, as regulations continue to become more stringent, we're seeing that these are moving even more upwards as many as monthly LDAR inspections. And so having that equivalency using alternative technologies is a benefit here. Additionally, these programs are considered from an economic equivalency. So not only are they wanting to be operationally efficient, achieving the emissions reduction, but also having that reduced economic footprint for operators to be able to use these and scale across their assets for program effectiveness and performance. So here in Alberta, CUBE has been working with 4 different operators. We've had 2 Alt-FEMP, so Alternative Fugitive Emissions Management programs, that were approved back in 2021. We've been working on those for almost the last 3 years. And we have two more recently that were approved in 2023. I'm going to be speaking about one of the programs that was implemented in 2023 with an Alberta-based operator. We were able to deploy close to 200 continuous monitoring CUBE devices on 46 facilities and multi-well pads. And these were selected on the basis of having those facilities that had meaningful emissions reductions. Multi-well pads often have the same kind of emissions, often even more than some of the facilities. And so we wanted to trial that using continuous monitoring with this approved work practice as part of this program. We were able to achieve 55% emissions reduction across the first 5 months. Often what we see in these programs is that there's low-hanging fruit that can be achieved through the use of this data, where operators can use the data, using real-time data to identify and alert on those issues and repair those quickly and be able to have that success. And then as they move towards these programs, we see continued success in understanding the data and then just developing that into their emissions and their operational workflow on a day-to-day basis. This program, we were able to achieve 46 tons of methane reduced, which is pretty significant in the first 5 months as well. This is ongoing, and so we will be continuing to work with this operator and achieving more of those emissions reductions as we go. Where we see this approval process, we highlight this into 5 different steps. And so I'm going to be talking about this specific to Alberta, but we find that this is often very equivalent across different jurisdictions as well in this same kind of flow. So an operator would select a technology, and this could be a combination of technologies. So the case that we've been working with, 3 out of our 4 Alt-FEMPs or Alt-LDAR programs have been using continuous monitoring along with OGI as follow-up. One of the 4 programs has an aerial component to it. And so it just depends on the technology selection that your team is interested in and what you may have experience with, maybe what the specific facilities may require. And so this can be a varied approach to that technology selection. The second is the site selection. And so we know that in different jurisdictions, some of these approvals are more of a all-encompassing technology approval. However, within Alberta, these had to be specific sites that were selected and carved out as part of these programs. The third step that needs to take place is equivalency modeling. So this would be a desktop exercise where a modeling program such as LDAR Sim would be used to determine within an approved work practice on the specific sites, how does that equate to the either targeted or exceeded emissions reductions that are expected here. So when we developed these, we had that target of 45% moving towards that 75% emissions reduction. And so how that equivalency modeling is built is it uses statistical analysis of the kind of sites and the type of facilities that are being used, modeled against using the technology with the appropriate follow-up at the appropriate timelines. How does that achieve those emissions reductions? And so when you can use these different kind of levers in this modeling practice, that can then determine, using this program, we will achieve the emissions reductions that we're anticipating. The fourth step I see is really critical here. This is the actual work practice implementation. And so in step 3, you can move towards a variety of different work practices. You may have to tweak these a little bit depending on what's going to be feasible and then what achieves those emissions reductions in the model. However, having that work practice implementation is a really key step here. And so this is involving the actual operations teams to say, now that we're using this data, now that we're achieving continuous monitoring, we're seeing these emissions events, how are we responding to those, in what time frame, and how are we building that into that day-to-day workflow to actually see the emissions reduction on the other side using this measured approach. The fifth step would be that performance reporting. And so this is how the regulators are using data to evaluate the performance effectiveness, whether or not we're actually achieving what we said we were going to achieve. Are there any nuances to the specific programs? A lot of these technologies are fairly new when they were implemented a few years ago or even just currently. And so there may be instances where these programs need to be tweaked a little bit or changed just to meet the needs of the operator or the technology provider or the regulator, all three of those. So we really see a lot of learnings from the performance reporting bit as that feedback as we're learning more within these programs. And so that's a really critical step. We've also seen that some of these programs have moved from more of a pilot stage into more of a full-scale approval. And those have been done after the performance reporting has been evaluated with the regulator at the time, with the operator, and then with the service providers as well, or the technology providers, and as we move towards more of that full-scale approval. How to think about these Alt-LDAR programs is that we see two different tracks here. The first is what we call interval LDAR. And so this is simply capturing volumes from sites that may be emitting in small proportions above baseline level. So if you think about a site, we can establish what a baseline level, what it may be emitting, what it may be designed to emit on a regular basis. As we start to see those levels creep up over time, there may be small leaks that are contributing to that move towards site level baseline or site level rate, that's above a baseline level. And when we can identify those on a near term or early term basis, we can have an operator do more of a facility deep dive for them to truly understand what's causing these small leaks. This may not be a large leak that's very obvious. It may just be a process inefficiency that needs to be addressed. The benefit to having continuous monitoring is that you can identify this up front, you can make the changes, and then have that identification of the resolution and see that baseline return back down to an optimal level afterwards. So this flow chart here just shows that we monitor continuously for emissions. We can track a certain number of sites that are emitting above that targeted baseline. In this case, we've shown top 20% deviating facilities. Those would be having a quarterly OGI follow-up. The thing to think about here is that this is OGI by exception, not prescription. And so the OGI follow-ups would be done, pardon me, on sites that have issues and that they're trending above that baseline, having that site rate elevation above where it should be. Any leaks that were found during those OGI follow-ups then would be tagged, repaired as per a normal regulatory procedure, repaired, and then brought back down and continuously monitored again for those emissions. So this is where we think about that interval. This captures, a proportion of the events that may happen from a facility. And the second is this, what we call a large leak response. Studies have shown that more than 80% of emissions actually come from a small number of events. Typically, only 2 to 5% of events are causing that 80% volume of emissions. So this is pretty significant. And with the temporal variability of emissions happening anytime for varying duration, being able to respond to these leaks very quickly is a big optimal consideration for these programs and makes them very effective when you can use data to find these leaks fast and fix them fast. This is a busy flowchart here, but really the essence is that you're monitoring continuously for emissions. If an elevated rate or site threshold is exceeded, an alarm would be sent to an operator, whereby they could go and do an investigation. Cube provides a probable localization where we're saying this is tank 1, this is separator 2, compressor 3, where we're identifying where our probable leak location is. An operator could then go and investigate that, doing an audio-visual olfactory screening to determine if that can be found right away. If they find that, they can repair that, monitor for that return back down to baseline, and continue with this process. If not, if they're not able to identify it, then an OGI visit would be scheduled. Again, looping back into that same repair procedure where then if that's found, repaired, and we return back down to that continuous monitoring. So having that large leak response, find and fix quickly is really key to having the large emissions wins that we're able to identify throughout these programs. So we find that having these 2 tracks really covers most of the bases for the kind of leaks that we see on these sites, and having the 2 tracks available where alarms can be generated on both means that it can be very meaningful for operators to be responding to the things that need to be responded to. And so we'll talk about that a little bit more in how we can make this effective and how we need to have alerts set properly for that to be, so operators aren't responding to nuisance alarms as part of these programs. With this program itself, the Alberta-based operator, as I mentioned, we saw that 55% reduction over the first 5 months. Despite the fact that these are called alt-FEMPs, with the F meaning fugitive, we found a lot of other emissions outside of just fugitives that were actually identified and reduced as part of this program. So this is a benefit to continuous monitoring in these style of programs where we saw non-routine venting, incomplete combustion, some other routine venting that we were able to reduce as well. So where we think about alt-FEMPs or Alt-LDAR, it can just be simply those emissions reduction, not always just fugitive. And we're getting better at even being able to distinguish between the 2 and having workflow appropriate to one track versus the other. We'll talk about 3 different success stories as part of this program. Sites varying from 60% to more than 90% emissions reduction over a very short period of time, combination of non-routine venting, fugitive emissions, and then incomplete combustion. We'll dive into some of these. For the first site here, this is a larger multi-well pad where we were seeing that the operations, there were ongoing emissions, often being localized to the northwest tank farm in this, identified in red here. And so we were seeing that there were issues with the PVPA, the pressure vacuum pipe away, having these ongoing emissions. And upon a detailed review with the operator, it was determined that there was a partially plugged flame arrestor that was found. So the flare was actually down towards the south of the site. We weren't seeing emissions happen there. We were seeing them back at the tank farm. The partially plugged flame arrestor was actually causing back pressure in the system, resulting in excessive venting from the tanks. And so that's why we were seeing it localized to the tanks. This operator replaced the flame arrestor in Q4 last year and saw an immediate drop, a step change in their emissions profile, resulting in more than 95% emissions reduction over a 5-month period. So this is pretty significant. I like to highlight this just to show that it's not always the exact source of the problem that's where the emissions are showing up on site. And so in this case, it required that detailed review to understand truly what was happening, but then being able to have that emissions reduction as a result of this fix. In this second example here, this was a case of fugitive emissions happening from a tank farm here on the far southeast of the site. We were seeing excessive venting where Cube's model were localizing to those tanks over a period of time. So you can see the ongoing emissions in the emissions profile down to the bottom right of the slide in red. An engineering review was conducted and found that there was a leaking PVRV. This operator was able to fix the thief hatch. However, they also determined that the gasket wasn't seating, so they took the tank out of service. This site actually requires more of a full shutdown to bring this tank into full repair. But for the time being, we saw that initial 90% in reductions, just identifying that thief hatch, taking that tank out of service. And when this operator can actually do a full site shutdown, we anticipate that those emissions then will remain low after that time as well. So in this case, that 90% emissions reduction, this was a true fugitive. This is what we like to find in these alt-FEMPs, but there are other instances as well that we see success in capturing these other emissions. The third site here, this is a larger site, and often when we are monitoring these larger sites, we recommend operators have both a methane and a CO sensor paired within our devices, and this helps us identify instances of incomplete combustion where CO readings may be higher. And so in this case, we saw just that. We saw elevated methane readings from the top here on that in the red and gray chart, the timelines, and on the bottom you see the CO readings really elevated above where they should be as well. And so that identified that we saw potential fuel gas slippage from the compressors. We were identifying that on site, we notified the operator that they should complete exhaust gas sampling from their stacks. And they did that, identifying that there was actually rich burn happening, resulting in that incomplete combustion. And so they tuned the system, resulting in a 61% reduction in emissions. And so we find that this is actually a fairly common instance where just having those two, the paired CH4 and the CO, as an indication of something happening from that fired equipment. Some of these may not be able to be found with OGI cameras, just the lack of that heat differential coming off the stack. Having that paired CO sensor helps us to quickly identify where there's fired equipment, where there may be emissions localized to that, and then have that tuning as a relatively low effort process to come in and reduce emissions from these kind of sites. So a lot of benefit here. We see this as a win. You know, some of these larger sites, incomplete combustion is often the challenge that companies are looking for solutions to help reduce. So what have we seen? You know, we've been doing these Alt-FEMPS, Alt-LDAR programs for the last 3 years. We've had a lot of success in doing them. We've also had a lot of learnings. The one big thing, obviously, the metric is how many emissions did you reduce, or what was the volume of emissions reduced? So in this case, we saw 55% emissions reduction within the first 5 months. That's fairly significant. We see this being ongoing. As I mentioned, there's often that low-hanging fruit that we can identify using the data to identify, fix, and then see the result of those repairs. The benefit of the continuous monitoring is that it often helps companies understand where capital can be put towards on sites that may have higher emissions, and then also that evaluation on the other end, where a capital program may be executed, and then you can really truly evaluate and measure the impact of that change and that investment in that site, having that data over time and over a large amount of operational and environmental conditions as well that help with that evaluation. We talked about having those emissions reduction be more than just fugitive. We can see incomplete combustion, we can see non-routine venting, routine venting. Having that ability to use continuous data and that work practice to improve operational efficiency and just overall improvement, this is a really big key piece of these programs. And we're seeing that a lot of operators are having those wins as they're involving their operations teams, using the data, and learning from those. And it's sort of that continuous cycle of improvement with their sites. One of the big things that we see is that alarm thresholds need to be very effectively set for program success. And so we understand that we're collecting data every 3 to 5 seconds. We don't want to be alarming so much that it's causing nuisance alarms with the operations team. So what we really have to understand is where the site baselines are, where they should be set, where those alarm levels should be set effectively, whether that be on an interval basis, exceedance above that site level baseline, or on a high rate where something could be alarmed immediately to understand that something very large is happening on site and needs to be responded to quickly. So having that optimal alarm threshold where you can maximize emission reduction while minimizing the operations time and really truly only doing OGI surveys or even follow-up investigations where really needed, and having the operations on site in the most logical places where we can say this is where the probable leak location is, that really helps us to be effective in these programs. And that consideration of site level baselines, really moving towards that, those can be changed over time. So as we come into a site, they may start high, an operator makes changes, and we can reduce those over time so that we're most effectively setting those alarm parameters for program success. One of the other big things that I really like to highlight here is that having an engaged operations team is critical for program success. It's not enough simply to have a work practice in place if it's not being implemented. And even then, if it's being implemented and not being effective in how we're using the alarms, how we're doing the follow-ups, and where we're seeing that success is really critical for these programs to continue on and for those emissions reductions to be achieved. And so we give a lot of props to the team that we were working with here in Alberta. They were very involved right from the get-go, and we've seen that success in that driving down of emissions. They continue to be engaged, and really it's part of just their day-to-day workflow now, is that they're using this data, they're understanding how the operations that they're completing on site, how those are impacting the emissions data, and how that can be used to most effectively be program efficient in these areas. We've seen a lot of success in the Alt-LDAR world over the last few years. We see that this is going to continue to evolve as we're receiving more data, more operators are becoming involved in these kind of programs, and as regulations continue to become more stringent, Operators are often going to be looking to these alternative technologies to be more cost effective, to meet the needs of their teams, and to have just that program success from a sustainability standpoint, wanting to keep more of their product in the pipe to sell rather than be emitted to the atmosphere. So we've seen a lot of learnings, we've seen a lot of success, and we look forward to continuing to work with operators in this area.